All right. So what we're going to do is we're going to solve, it's called the balance method. Now, what you have to think of in this case is, have you ever seen those old-fashioned scales, right? Like a bar across the top, and there's little chains hanging down, right? And there's little kind of plates on either side. So if you put something on one side, obviously it tips, right? So you have to put what on the other side? Something of equal weight. If you put something of equal weight on either side, will it balance? Okay. That's how this works when we're solving equations. If you do something to the right-hand side, guess what you have to do to the left? The exact same thing. So if you divide by 2 on the right, you need to divide by 2 on the left. If you add 3 on the right, you have to add 3 on the left. It's as simple as that. It's kind of like the box method, which I showed you, but we're going to do it just straight algebraically. We're just going to do it straight with numbers, okay? So this is called solving by balancing. What do we got today? November 22nd. Okay. So let's start with something basic. Okay. 3x plus 2 equals 5. Okay. Now, can anybody just look at that question and tell me what the answer is? It's 1? Is the answer 1? Is x equal 1? Right, 3 times 1, 3 plus 2 equals 5. Yeah, okay, that's right. Okay. Now, what I want to show you is, how do we get 1? How do we get it algebraically? How do we solve this? Okay? So here we go.
But you know how you said you equal it out? When you're doing it, you always change a multiply by divide.
Okay, so we always do the opposite, right? And I'll show you that. That's another step to it. Okay. Now, guys, let's make sure this clear. I'm going to ask you this a couple times, and I want you to respond at the same time. The key to solving any equation, right, this is the key, is to get the variable, right, in this case it's x, by itself, right? It'll be like x equals something, or something equals x, but x has to be by itself. The other number could be a positive, could be a negative, could be a fraction, could be a decimal. Who cares? As long as it's x equals something, or whatever letter equals something. Okay, so the key to solving any equation is to get the variable. Try that again. By itself. The key to solving any equation is to get the variable. That's exactly it. I'm going to ask you that constantly. Because does that rule change all the way up through grade 12? No, it's the same rule, right? No matter how complex the equation gets, you're always trying to get it by itself. First off, look at this. Is x by itself? No, there's a bunch of crap with it. Look what's attached to it right now. A 3. Oh, and there's also this 2. It's hanging out. Okay. It's not by itself. Can we get rid of some of this stuff? Yeah, let's move it around. What do you want to move first? Okay, you want to, let's get rid of this 2, right? Let's look at this 2. Let's look at this 2. Can we get rid of this 2? We have a positive 2 there. I have positive 2. How do I get rid of it? I subtract 2. Is that correct? Okay, I'm going to subtract 2. Right there, just like that. Now, here's where the scale comes in. If I subtract 2 on the left, what do I have to do on the right? Subtract 2 on the right. There it is. Does that make sense? It has to balance. You have to do the same thing on both sides of the equal sign. The equal sign is the center of the balance, right? And it has to be on either side. Okay. Now, what happens? What's 2 minus 2? What happens to these guys right here? They're gone, right? They're completely gone. Okay, so what are we left with? 3x. Okay, now, here's another thing that will keep you organized. When you write this out and you work your way down, try to keep your equal signs lined up. It's a simple thing, but it actually will help you keep your work organized. It'll help you as you're going along, because if you start to move things all over the place, you'll get lost. Now we do this. What's 5 minus 2? 3. Okay. We're done, right? X is by itself? No, x is not by itself yet, right? Because the key to solving any equation is to get the variable. That's pathetic. The key to solving any equation is to get the variable. That's better. Okay. Now, x is not by itself. What is stuck with this x? A 3. But how is the 3 attached to it? No, it's what? Multiplied. Because when they're side by side, right? The variable and the letter, when they're side by side, it means multiplication. So if we multiply by 3, what's How do we get rid of it? You divide by 3. Do you see you do the opposite of what it is? Okay. So if we, watch here guys, if we take this and we divide by 3, what do we have to do to the right side? Divided by 3. Okay. What happens to these 3's? They cancel out, because anything divided by itself is wrong. 1. So they're gone, right? So these are gone. X equals 1. We knew it was 1, didn't we? Yeah, we could look at the original equation and see that. Could you test it? Could you test to see if that's the answer? You take it and you plug it into where? Into the X in the original equation, right? So you take it in. What's 3 times 1? Plus 2? Does the left side equal the right side? 5 equals 5, right?
Yeah.
Easier than box method, do you think?
Yeah.
Is it? Really, it's the same concept, right? With what? The box method takes more time, but it's the same principle, isn't it?
Well, when I was doing this and I kind of pictured the box.
Okay, so when you pictured the box, when you saw that it was a plus 2,
I had to do it at the bottom.
yeah, it's basically what we did in the box method, because if it's plus 2u, minus 2. If it's multiplied by 3u, divide by 3. Wasn't that the bottom of the box method? It was the opposite of the top part. Makes sense. Okay, let's try another one. No, let's do this one. 2x minus 3 equals 7. Okay? And again, we could probably look at this, figure out what the number is. What is x in this case? Before we even get going, does anybody know? 2. No, it's not 2. 5. 2 times 5 is 10, minus 3 is 7. Okay, so we know the answer is 5. Okay, but let's do this algebraically. What are we going to move first? Now careful. It's a negative 3. So what's the opposite of negative 3? So I'm going to add 3 to this side. What do I do to this side? Because you have to always keep it in balance. Okay, what happens to these 3's? The first ones? They're gone. You're left with? No, you're left with? 2x equals 7 plus 3? 10. Okay? Did I line up my equal signs? Yes. The reason I show you that is because then your math teachers in 10, 11, and 12 will be happy. You'll keep your work organized. It also, if you're showing your steps and you go wrong at any point, it's easier for your teacher to help you find the mistakes. Actually, it's easier for you to find the mistakes. Now, is the variable by itself? No. What's attached to it? A 2, and how's that 2 attached to it? So what do we do to get rid of it? We divide. Beautiful. One side or both sides? Both sides. Okay, 2 divided by 2, what happens to them? Don't say 0. 1, so they cancel. We're left over x equals 5. Much easier, isn't it? Yeah, you learned it in grade 8. But the thing was is you learned it a basic concept in grade 8. Are we going to get really in-depth in this one? Yeah, we're going to start throwing fractions in. We're going to start throwing decimals in. We're going to start throwing lots of brackets in. We're going to multiple variables. Yes, I know. The continuation, right? But we have to start with this because some of you probably have forgotten this, haven't you? All right. You got that? Okay, here we go. Next one. All right, here we go. 3x plus 1 equals 2x minus 3. Uh-oh. What's different about this one? There's stuff on both sides, isn't there? There's variables on both sides. But the rule still applies. The key to solving any equation is to get the variable. Guys, that's pathetic. The key to solving any equation is to get the variable. Right. Now, x is not by itself, right? It's all over the place. We got a 3x on the left side. We got a 2x on the other. We got a 1 over here. We got a negative 3 over there. Well, the interesting thing about algebra is you can move stuff around all you want as long as you follow the rules, which means if you do something to one side, you do it to the other. Okay. What do you want to move? Take a guess. We have 4 things we can move up here. What do you want to move? You want to move the 1. Where do you want to move it to? So you want to move it to the other side. Okay, let's try that. Let's see if that works. Okay, so we're going to subtract the 1 there. If I subtract 1 on the left side, what do I do on the right? Subtract 1. Now, do you notice when I write those, do I write it over and down a bit to the side? If you wanted to Could you do this? Watch it. I'll erase this in a sec. But could you do it this way? Minus 1 equals 2x minus 3 minus 1. Could you write it out in one whole line? So then, oh yeah, that cancels out, right? Some people don't like that because they think it confuses them a bit because they see it on both sides. I don't mind. You can do it either way if you want. It is, but it'll keep you balanced out properly sometimes. You have to, you might notice you have to give yourself a little bit of room when you do questions like this, because you need some room to write all these little extra pieces. Don't put it in front of the number, like if it's minus 3, minus 1, don't put the minus 1 here. It's just bad habits. It'll screw up your signs eventually if you're not paying attention. Okay, what happens to the first ones? 1 minus 1. What happens to those? They're gone. Okay, so 3x equals 2x, negative 3 minus 1, minus 4. Okay, well, that's not bad. That's better already. It's better so far. You agree?
Yeah.
Went from 4 terms down to 3. Okay, now what do you want to move? You want to move the what? Okay, now careful with this one. This is where students get confused. We want to move the 2x. Not just the 2 and not just the x. We want to move that whole term 2x, right? We want to move the whole thing. We want to move it from the right-hand side to the left-hand side. Now, is it positive 2x or negative 2x? Right here. Now, what's on the board? Positive 2x. So I have a positive 2x. How do I get rid of it? I subtract 2x. Okay. What do you think most people do in that case? They divide. Yeah, that's exactly what they do. They divide by 2, right? That's what you're trying to do. You're not just moving the 2. You're moving the whole term, the whole 2x. So then you subtract 2x. On this side, what do you do on the left? Subtract 2x on that side. Awesome. What happens? What's 2x minus 2x? You went in for 2 x-rays and you actually didn't have any x-rays. There, right, so they're gone, right? 3x minus 2x is x, 1x, or just x, however you want to say it. And what's the answer? Negative 4. Yeah, ask.
3 minus 2 is 1x?
Which one? Right here? So yeah, 1x. So could you put a 1 in front of this x?
Oh.
Or just x by itself, right? We assume, right, that when it's an x like that, there's a 1 in front of it. Okay? Is the variable by itself? Could you check the answer? Can we plug it back into the original question? Okay, there's one. You want to try one on your own? Yes, you do. By the way, it doesn't make any difference whether you move the x's to the left or move them to the right. But most people like it when the x is on the left. They like the variable something equal to something else, but it doesn't make any difference. You'll find out in a minute. Okay? So 7x plus 3 equals negative 5x minus 15. I want you to solve for x. What do you think you're going to move first? Let's just kind of talk about that. What do you want to move first? The 3? Sure. You'll move the 3 to the other side. And then what do you want to do after you move that one? What do you want to move next? The negative 5. Yep. The negative 5x you want to move. So move the 3 first, then move the negative 5x, then you probably have a division as your last step. Move the 3, move the negative 5x, then you probably have a division. Should have 3 steps basically when you're done. And then if you think you have the right answer, verify it. You can see right away if you have it or not. Cameron, turn around. Move the 3, move the negative 5x, then do division. What'd you get as an answer? What'd you get? Negative what? What'd you get? No.
Why did Steve put mine at 15 and I got a redeal on one? Because
What'd you get?
negative 6.
Nope. Try it again. Don't forget, guys. I mean, this This is pretty tricky stuff. Algebra is the stuff that really confuses people. This is probably one of the hardest topics that you'll see. But it's probably one of the most crucial because it helps you in all your other math. 10, 11, and 12.
I just don't understand.
What did you move first?
Back to 3.
From both sides?
Yep.
Okay.
And
Then what did you do?
I
Then you
go positive 5.
positive 5x, right? You got to move the whole thing.
Added 5.
5x or just 5? Okay, good.
Right, and then I added that 6, so 12x. And then it equals negative 18
Okay, and then what did you do? Divide by?
by 12.
Okay, so what is 18 divided by 12? Do it.
Lie to me.
Use your calculator if you don't know. 18 divided by 12. You had all the numbers right, but because you listened to somebody that gave you the answer, and gave you the wrong answer,
Negative 1.5.
you get negative 1.5, right? Because one of those is negative. So you would have got the right answer. Yeah? What'd you get? Over. Oh, see, hang on. 12. Okay, so you got that part. You're missing just the last step. Okay, let's do this. Okay, just hang on. We'll do it. Okay. So guys, what did you move first? What did you move? 3. So you minus it from one side or both sides? Both sides. Okay, here we go. So those are gone. So what do you end up with? 7x equals negative 5x. What's this? Negative 18. Good. Most of you got that so far. Okay, then what did you do? You moved the, careful here, you moved the whole negative 5x, not just the negative 5. You moved the whole negative 5x. So to do that, what do? You add 5x. So then what do you do over here? Add 5x, right? Because left side has to equal right side. Okay, these are gone. So what's 7x and 5x? 12x equals negative 18, right? That's where you got to, right? Okay, is x by itself? No, what's attached to it? And how is that 12 attached to it? Multiplication. So then we need to do the opposite, so we need to divide. One side or both sides? Both sides. Okay, so we divide by 12 and we divide by 12. Those are gone. X equals negative 1.5. Okay. The questions have gotten more complex, but the pattern's still the same. What's going to really vary is the number of steps to get to the final answer, right? They're just going to start increasing in number of steps, right? Right now there's 3 steps there. We can get upwards of 5 or 6 or 7 steps to get to the end product. Okay, let's try another one. But let's, yeah, I'll let you get right down. Yeah. I'll show you in a sec. It's actually, you may see fractions, but I'm going to show you a method that will make them really easy. What? No, you'll see right away. Trust me, I've been doing this for a while. You have to do fractions because you will see fractions in 10, 11, 12. Do you have this down? Okay. Okay, so now the next one we're going to add some brackets in. Okay, so here we go. Okay? So we have 5 and in brackets, x minus 7 equals negative 15. So guys, the rules of this are still the same. To do this, you have to get the variable. That's a little better. Okay. Is the variable by itself? No, it's got a 7 in there, it's got some brackets, it's got a 5 out the front. What do you think you do first? What? No. No, you got the brackets. That's the key thing, yeah?
Multiply 5x, multiply 5.
You got to get rid of the brackets, right? Like, think about BEDMAS. Is the first thing you do is brackets? It's the same thing here. You got to get rid of those brackets so you can get x by itself. What's that called? That property, we talked about it. When the number's out the front and you have to kind of give it to everything in the brackets. Sharing property? Distributing. Distributive property, right? Distributing. I'm giving things out. I'm distributing things. So what am I distributing? Which number?
5.
The 5. Okay, so we're going to do this, guys. We're going to go 5 times x and 5 times negative 7. Okay, what's 5 times x? 5x. Easy. 5 times negative 7? Negative 35 equals negative 15. Now, does this look like the stuff we've just finished doing? Yeah, right. Let's get rid of the brackets. Now we're back to the stuff we've done already. Right? What are you going to move first?
35.
The what?
Negative 35.
Thank you. We're going to move the negative 35 first. So what's the opposite of negative 35 or subtracting 35? Plus 35. So what do we do to the right-hand side? Plus 35. Yes, these are gone. What are we left with on the left? No, what are we left with on the left? 5x equals 20. We're done, right? No, the key to solving any equation is to get the variable. Is the variable by itself? No. What is attached to that x? A 5. And how is it attached to that x? By multiplication, so we need to do division. We do the opposite. Okay, so if we divide the left side by 5, what do we do to the right? Okay. Is this starting to make sense? Yeah. So it means the same thing, right? Okay, watch. Just hang on. So what is x now? What's 20 divided by 5? 4. Okay. So you just asked, what if it was this way? What if instead of 5x, it was x5 equals 20? Now think about that for a minute. When you multiply numbers, does it matter the order? Is 3 times 4 the same as 4 times 3? Okay, so is 5 times x the same as x times 5? So we still need to get 5x by itself. How are they attached? Multiplication, so how do we get rid of it? We divide. You do the same thing, right? Doesn't matter that it's backwards or forwards that way. Yeah. And we get rid of that. Okay, now, same principle, brackets, but we're going to throw some decimals in here. So you might need your calculator for these, and see if you can do this without a calculator, but it might not be possible for you guys. 8.4 equals negative 6, a plus 2.4. Okay? So I'm switching it around. Switch to a different variable, which you'll see, and I've moved the variable to the right-hand side now instead of the left. Big deal. You treat it exactly the same way. Do you need to get a by itself? Is that the whole goal here?
Yes.
Okay. Right now, is it by itself? Bunch of junk attached to it, including some brackets. What property are you going to use? Distributive property. Give that a shot. Distribute that negative 6. Come on, guys. Do this question, please. Write it down and do it. Distribute the negative 6. Write it down and do it, please. Write it down. Get your own calculator. Then take your own calculator back and get your own. You can, but try not to rearrange it just yet. What happens is if you get better with this, you'll start to rearrange it if you like. But after a while, you realize it doesn't matter if the answer equals A or A equals the answer. You'll be able to figure it out both ways. Distribute that negative 6. That's the first thing. Then probably do some addition or subtraction. That's the next thing. And then probably a division is the last thing. Treat it just like it's a variable, right? Treat it just exactly the same way. The only difference is instead of an x, it's an a. Nope. Negative 3.8. Not bad? You getting this? Yep. Yeah, go ahead. Leave the door open so you get back in.
Would be negative or what?
Neither.
I don't know.
We'll find out in a sec. Okay, what do you do first? What do you do with the negative 6? What's that called? What's that called? Distributive property. Okay. So let's figure this out. So 8.4 equals, what's negative 6 times A?
Negative 6.
Negative 6A. What is negative 6 times positive 2.4?
Negative 14.4.
Negative 14.4. Okay. So hopefully you have that line correct. If you don't have that line correct, obviously everything else after that's going to be wrong. You have to be able to do distributive property like flawlessly. Okay. Now, what are you going to move next?
The 14.4.
The negative 14.4. We're going to move it to the other side. Is that right? Okay. How do we move this negative 14.4? You add 14.4 to the right side, so what do you do to the left? Add 14.4 to the left side. Okay, these are gone. So what's 8.4 times, plus 14.4? 22.8 equals negative 6A. Okay.
Okay. Oh, because we did...
You did it the other way. Did you move the negative 6A?
No. Yeah. No. We divided.
No, the division is the last step. Every time we've done this, the division has been the last step, hasn't it?
You check that. I don't even know. Yeah. So confused. I don't know what you're wrong.
Yeah, right here. That's negative 14.4, and you have positive. That should be negative there. So then what did you do here? You did these backwards, right? So that should be plus. Then you divide by negative 6. So this is your mistake right here. That's negative, and both of those should be positive. You just made a sign error. You did the procedure right. You just have the error in the signs. See, look. Because that's negative 6 times positive. That should be negative there, and you have positive, right? So then you subtracted 14.4, and you should be adding 14. So then obviously this number is wrong on the left, right? Okay, now, is A by itself? Is A by itself? What is attached to the A? No. What? Negative 6. You have to make sure you understand that it's a negative 6 attached to the A. Now, how is the negative 6 and the A, how are they stuck together? By multiplication, so we need to divide. Now, what do we divide by? Wrong. Negative 6. What do you think the most common mistake is? To divide by 6. Huge mistake. You have to realize whatever's in front of that variable, if it's negative or positive, is what you divide by. If it's positive 6, you divide by positive 6. If it's negative 6, you divide by negative 6. So you divide by negative 6 on that side, you divide by negative 6 on that side. So A equals negative 3.8. Yeah.
If I typed it on my calculator, negative 6 divided by negative 6 is 1.
Negative 6 divided by negative 6 is 1.
So then where does it go?
What's in front of this A? What did you just tell me is in front of that A? A 1. Do we need to write it in? No. Right? You don't need to. Could you write it in? Is it wrong? No. Either way. Okay, let's do another one. Guys, please. Yeah. As you can see, these are getting more and more complex. What do you do first? Distribute. Get rid of the brackets, guys. Do that first. Write this down. Get rid of the brackets. That's your first step. Make sure you can do that. So you need to go get a drink of water. So there and back, even though you're not supposed to be out of the room at all.
But just focus or...
You know what? Don't play those games, please. Okay, so get rid of the brackets first, please. Get rid of the brackets. Let's just double check that you got that line correct. Because, I don't want you to go forward if you're getting that wrong. Okay, so what's 2 times x? 2x, 2 times negative 3? Negative 6. Minus 5 equals 13 minus 4x. Okay.
Right there, just minus 5.
Okay, so what did you just ask?
I
Now, so what he's doing is before he's moving anything around left and right hand side, can he simplify that before you get going? Can you simplify the -6 and the -5? Yeah, you can, right? My recommendation is do that first. Is it less stuff to move later on? Oh yeah, it's way less stuff to move later on. So if you can simplify on the left side before you even get going, or the right side, do that. So look here. Can we do the -6 minus the 5? Yeah, okay, so we end up with 2x. What's -6 minus 5? -11, right? Is that correct? Equals 13 minus 4x, right? All of a sudden we went from 5 terms down to 4. Okay, now, take a minute and move things around. Try to get x by itself. It doesn't matter if the x is on the left side or the right side. You just move things around. So you're either going to move the -11 or the 13 first. That's what you're going to do. As you get better with this, you can actually start doing multiple steps in one shot. You can double move things in one shot. Takes a bit of practice, but you'll get the hang of it. So move it around and try to solve for x. And you'll see if you get the right answer. What is the right answer? It is... What is it?
4.
Yep. Once you get the hang of algebra, it's actually quite interesting to do. Like it's stuff that scares people a lot.
Really screwed up here.
What'd you get? You're not done yet? All right, guys, give this a shot, please. I'll give you a minute. Yes? You guys done yet or no? No. One answer. Now, if you were ever to ask, like, hey, is the answer 4, right, if you're asking that, could you check? You just go back to the original. You're going to have to start verifying these. Interesting thing is, when you do this on a test, let's say, you should never get one wrong, right, because you can always test it. And, you know, the grade 11 pre-cal that I teach, I get them to do that. They actually have to verify it, so they plug it back in to see if they get the right answer.
It's like pre-cal.
This is what, if you went into pre-cal, this is really a lot of pre-cal. Because it's formulas, right? It's actual numbers. Like, there's not a lot of, you can do it without a calculator. Computer? Yeah, go ahead. Okay, so what did you guys move first? Tell me what you moved first. Did you move the 11? The -11, right? Okay, guys, how do you move the -11? Add 11, so if you, okay. If you add 11 to the left, what do you do to the right? Add 11. Now, you see where I wrote it? Just to the right and below the 13, just to make it clear? What happened to the first two 11s here? They're gone, right? So what you're left with 2x equals, what's 13 plus 11? 24 minus 4x. Okay, what are you going to move next? You're going to move what? I'm trying to get you to make sure you speak correctly, right? Are you moving the 4x or are you moving the -4x? -4x. How do you move the -4x? You add 4x. To the right side, what do you do to the left? Add 4x. Okay? What happens to these two over here on the right? They're gone. So what's 2x and 4x? 6x equals 24, right? Well, no, because we're adding 4x. I'm making sure it's not a positive 4x. Well, I guess technically it's the same thing. But I'm putting that there so I know that I'm adding 4x. Because it's the opposite of -4x, right? Okay. Now what do? Is x by itself? You got to divide by 6. One side or both sides? Both sides. X equals 4. Yeah? So far so good?
So far, so good.
Alright, you're not gonna like this one.
But you want to live.
Fraction.
No, not yet. Well, we still got one more before we hit fraction. Oh yeah. Yeah. You can, hey, you can always print up the notes if you miss them, right? Okay. Here we go. Sure. Guys. Okay. There it is.
They all get the right answer.
Now, before you get rolling on this, after you write it down, but just before you get rolling, just listen, please. The one that's going to screw you up in this whole thing is this one right here. The negative that's in front of the x plus 3. Because when you try to distribute that, you have to remember, what is between the negative and this bracket? A 1. So you're actually distributing what number? Negative 1. So if you want, can you put in a negative 1 in front of that thing there? So you might want to do that. That's the one of this whole thing that's going to screw you up. So you're going to do 3 distributions here. Okay? 3 distributive properties. Then collect some like terms, and then start rearranging stuff and see what you can get as an answer. And we'll see if you get the right answer when you're finally done. That's right. That's exactly how you have to think of it. Negative 1 times 3, just like you said.
Hi.
Distribute. What do you mean? Distribute the 3. So distribute this one first. What's 3 times 2x? So here's what I want you to do. I want you to actually draw the line in like that so you do it. So what's 3 times 2x? So write it down. Yeah, get rid of that number there. And then draw the next line and do the calculation. If you do it that way, if you do it that way, you will make less mistakes. You'll get faster at it. Don't worry. No, you have to try it. That cannot equal 0. So you cannot have h in this case, right? Because it's below. You cannot have it equal to 0. Because if you try to divide anything by 0, what do you get in your calculator? Try it. You get an error. It's undefined, right? So that's why it can't be 0. So the bottom denominator can never be 0. Yeah. What? Maybe. What'd you get? Why not? Where do you get stuck? Like the line after the distribution? Okay, so then collect as much as you can. So if there's any x's, collect those together on the left and right hand side. Then start moving things around. You'll see that there's some stuff that you can collect. Well, let me show you something here.
No, I mean like this.
No.
Yeah, I definitely did get someone to.
No, not that stuff.
No, just hang on.
I'm so long.
Okay. This, which you see on the board, right? Like this is grade 11 pre-calc. That's the same concept. But the rules that you're doing here are exactly the same. So when you see brackets, you try to get rid of them. So in this case, there's no brackets in this first trinomial. We actually create brackets to make it easier for us. But the rules are going to be the same when you hit this stuff. I guarantee you'll remember back to grade 9 and the rules, and you'll be like, I remember these rules. They don't change as they get more complicated. They just start to get more complicated. Okay, so guys, just hang on. Let's try the first line here. Let's try the first line. What, now, as I was saying to Pascal, draw the lines in and do the calculation if that helps you keep organized. So what is 3 times 2x? 6x, right? Guys, look, watch up here on the board. Now we go 3 times -5. Negative what? 15. Okay, now what did I say was between the negative and the bracket? A 1. So I'm going to draw it in there just so I can see it when I do my distributive property. So what's negative 1 times x? Negative x. What is negative 1 times positive 3? Negative 3. Equals, I'm going to do this here, 2 times x, 2x, 2 times 1, 2, and what's left over? A 4. Okay. So we got this really big line. We got rid of our brackets, but we have a really big line. Before you start moving things around, left and right, can you collect the stuff that's the same?
Yes.
Didn't we do collect like terms?
Yes.
Remember polynomials? We collected like terms. If they were both x squares, we could collect them. If they were both y's, we could collect them. If they were both constants, we could collect them. Okay. Now, on the left side, what's the same? 6x and x. So you were supposed to go in for 6 x-rays, but they didn't do one of them. So how many x-rays did you have? 5. Okay. Could that be no? But 6x minus x, right? There's a 1 in front of that x, right? So 6 minus 1. Okay, now guys, negative 15 minus 3. Negative 18. What'd you put? Okay, so you have to make sure you don't make those mistakes, okay? Those are easy ones to avoid. What about the right-hand side? Is there anything we collect? 2x plus 6. Okay. Now, if you look, all of a sudden we've gone from that big, long set of terms. Just pick it up and leave it on your desk, please. We've gone from these long set of terms down to 4. Now, what do you want to move? You want to move the negative 18 to the other side? Okay, how do we get rid of the negative 18? Add 18, so what do we do over here? Add 18. Good. What happens to these two here? They're gone, right? Negative 18 plus 18, they're gone. So what are you left with? 5x equals 2x plus 24. Okay, what do you want to move next? The positive 2x. We're moving the whole 2x. So how do we get rid of it? We subtract 2x and we subtract 2x. Okay, what happens to these guys here? They're gone. What are you left with? 3x equals 24, right? Guys, we're still trying to get x by itself. Is x by itself? What's attached to it? A 3. How is the 3 attached to it? Multiplication. So how do we get rid of it? We divide one side or both sides? Both sides. Those are gone. X equals 8. Now, do you see that the process is still the same even though they look more complicated? Okay. So what we'll do tomorrow is we'll do fractions tomorrow. We'll continue that lesson, do fractions.